Greetings! In this video we will discuss pipelines in KubeRocketCI. This video is part of the updated KubeRocketCI 3.13 series that reflects the new UI, current terminology, and updated platform workflows. In previous versions and in some technical resources, you may still see the term deployment flow. Starting with KubeRocketCI 3.13, the user-facing term is deployment. We will get familiar with what a deployment is, how it's structured, deployment strategies, and the pipelines that power the deployment process. Before we dive into pipelines, let's quickly establish what CI/CD means, because deployments are the CD part of that picture. Continuous integration covers everything from the moment a developer makes changes in the code to building a ready-to-use artifact. Continuous delivery takes it further, delivering the artifact to the environment, where continuous deployment, in turn, handles running it. Automation in CI/CD is implemented through pipelines. A pipeline is a set of sequential steps that accomplish a specific development task: building code into an artifact, automated code review, running linters, or deploying an application. You can think of pipeline as sophisticated scripts that run automatically in response to certain events, like a code commit or a merged pull request. A fully prepared and pre-configured set of pipelines for all major processes is one of KubeRocketCI's key features. While other solutions only provide CI pipelines by default or don't offer pre-built pipelines at all, KubeRocketCI delivers everything out of the box, so you can focus entirely on building your application. Now let's get familiar with deployments in the context of KubeRocketCI. While a deployment in Kubernetes is a resilient logical group of pods that share the same lifecycle, a KubeRocketCI deployment is a Kubernetes custom resource that defines how your applications are delivered to target environments. It acts as the CD layer of your platform, grouping environments together and configuring how applications move from one delivery stage to the next. Think of it this way: CI pipelines build and test code and produce an artifact. The deployment takes that artifact and delivers it to the right place, in the right order, using the right strategy. KubeRocketCI provides 7 pipeline types organized into 3 groups. The CI group includes review and build pipelines. These run before code reaches a production environment. The CD group includes deploy and clean pipelines. These handle delivering and removing applications from environments. There are also 3 standalone types: security, test, and release, that run on demand and cover more specific or project-defined workflows. We'll briefly mention them in the portal, but won't go into detail here, since their use varies a lot from project to project. Let's look at each of the core pipeline types. The review pipeline runs when a pull request is created. Its goal is to validate the source code before it can be merged. First, the code is cloned and initial values are set up. Then, the code is compiled and analyzed with SonarQube, surfacing code quality issues, coverage gaps, and potential bugs. Finally, the Docker file and Helm chart are linted, and the test container image build is verified, without pushing anything. The results feed back into the pull request. The build pipeline runs when a pull request is merged. Its job is to take the reviewed code and turn it into a deployable artifact. It starts by fetching the source code, initializing values, and resolving the artifact version. Then the code is compiled and analyzed with SonarQube. The same analysis as in a review, but now against the merged state. Finally, a container image is built and pushed to the registry. The commit is tagged in Git, and the codebase image stream is updated, so the platform knows a new version is ready for deployment. When a deployment is triggered, KubeRocketCI runs the deploy pipeline. First, a pre-deploy quality gate runs, verifying that conditions are met before anything is changed in the cluster. Then the application is deployed via Argo CD. An application set is applied and Argo CD syncs the desired state to the cluster. A post-deploy quality gate follows, validating that the deployment completed successfully. Finally, images are promoted, making the artifact available for deployment to the next environment in the chain. When an application is no longer needed in an environment, you can safely remove it using the clean pipeline. First, a pre-clean gate runs, checking that the removal can proceed safely. Then the application is removed, gracefully taken down from the cluster and deregistered from Argo CD. Finally, a post-clean gate verifies that the cleanup completed without leaving orphaned resources. As the note at the bottom explains, the delete button removes resources in Argo CD immediately, with no pipeline. Clean runs your full removal logic first, giving you control over the process. A key part of setting up a deployment is choosing a deployment strategy, the trigger mode that controls when the deploy pipelines run for each environment. Manual requires the user to explicitly trigger the deployment by clicking the Start Deploy button in the portal. Use it when you want full control over when releases happen. Auto-deploy triggers the pipeline automatically as soon as a new artifact version is built. All applications in the environment deploy at once, each at their latest version. Auto-stable also triggers automatically, but deploys new versions one at a time. Let's look at what that difference actually means in practice. Say, 3 applications in your deployment all get a new build within minutes of each other. All 3 now have a v3 latest. With auto-deploy, one pipeline run fires, and all 3 deploy simultaneously at v3 latest. With auto-stable, they queue up. The first pipeline run deploys app 1 at v3 latest. Apps 2 and 3 stay at their v2 stable, the last version that was successfully deployed. Second run deploys app 2. App 1 is already at v3. App 3 is still holding the stable version. And the third run completes the queue. App 3 gets the latest version. All 3 applications are now updated, but each went through its own dedicated pipeline run. This is the key guarantee of auto-stable. Every new version gets the full pipeline treatment before the next one rolls out. All pipeline runs can be monitored in the KubeRocketCI Portal. The dedicated CI/CD pipeline section gives you full visibility across all runs, from any project or environment, in one place. From there, you can check statuses, stop or restart runs, and even edit pipeline definitions or individual tasks. Now that you know how pipelines work, let's run all 4 types in the portal. Navigate to the Project section and open your project. Go to the Branches tab and click the branch name where you develop your change. We have already created a commit to quickly get down to creating a pull request. Let's create it right from here. Switch back to the portal. The review pipeline has started automatically. Know that all pipelines in this demo are sped up. As you can see, the review pipeline validates the code before it can be merged, running the source code analysis with SonarQube, linting the Docker file and Helm chart, and verifying the container image build. The review pipeline passed. Let's merge the pull request. As soon as the merge happens, the build pipeline starts automatically. The build pipeline compiles the code, runs SonarQube analysis against the merge state, builds and pushes the container image to the registry, tags the commit in Git, and updates the artifact version, so the platform knows a new version is ready for deployment. We now have a build artifact. Let's deploy it. Navigate to the deployment section and open the deployment we prepared for this demo. For this demo, we are using the manual deployment strategy, so the deploy pipeline only runs when we explicitly trigger it. This lets us control the exact moment of deployment and makes it easier to follow along. In a real setup, you might use auto-deploy or auto-stable depending on your environment. Click the Configure Deploy button. Select the newly built version and then Start Deploy. You can find the pipeline run in the Pipelines tab in the environment. The deploy pipeline is now running. It starts with a pre-deploy quality gate, then deploys the application via Argo CD, runs a post-deploy gate to validate the result, and finally promotes the images, making the artifact available for the next environment in the chain. The application is deployed, and its state is now managed by Argo CD. The portal indicates that the application is running. You can also verify this by opening the Argo CD application resource. As you can see, Argo CD shows the application resources have been deployed. Now let's remove it using the clean pipeline to see how the removal process works. Navigate back to the environment. Click the Clean button and confirm the cleanup. Notice the difference between clean and delete. Delete removes resources in Argo CD immediately with no pipeline, and can target specific applications when you have multiple. Clean runs the full removal sequence, giving you control over the process and ensuring nothing important is left behind. The clean pipeline runs its pre-clean gate, gracefully removes the application from the cluster, and runs a post-clean gate to verify the cleanup completed without orphaned resources. Finally, let's look at the CI/CD pipelines section. This is where all pipeline runs from across the platform appear in one place: review, build, deploy, and clean, regardless of which project or environment triggered them. From here you can check statuses, stop or restart any run, and even open the pipeline definition to add tasks directly. That wraps up our hands-on walkthrough. We ran all 4 core pipeline types end-to-end and saw where to monitor them in the portal. Thank you for watching. If you have questions, visit our documentation or reach out to the team. In the next videos we'll go deeper into environments, pipeline customization and related platform workflows. That's it, have a great day.